let's use the rules of exponents to simplify these expressions. So let's start with this one. Okay, so it looks like we have multiplying. We are multiplying two numbers with the same, two exponents with the same base. So it looks like we're going to be using this, my product of a product, which says I'm going to add the exponents. So n to the second times n to the fifth, if I add those together, that'll give me n to the seventh. And anytime I have two numbers just being multiplied, that's just 6 times 2. So that'll be 12n to the seventh. Next, for this one, now this is not like the two like bases where we keep the bases and add the exponents, because notice here that 2 doesn't have a base. So this is a power to a power, which means I multiply those exponents. So that'll give me 8 to the 6th, but I still have 8 to the 6th times 8 to the 4th. So now I am going to use this product rule, and 8 to the 6th times 8 to the 4. Again, I'm going to add those exponents, and that will give me 8 to the 10th. Now for this next one, again, I am using this power of a product rule, which says I keep the bases but multiply the exponents. But notice I have two different exponents inside of these parentheses. So this has to, it's kind of like a distributive property for exponents. So this will turn into x to the 12th times y to the 6th over x to the 5th times y to the 8th. Now notice I'm only doing one exponent rule at a time, but as you get better at this, you may decide you want to start using multiple rules. Now remember, all of these rules have to do with the same base. The bases have to be the same in order for us to use these rules. So I can't apply the rules to x over y, but x over x I can, and y over y I can. And this is the division rule. And the division rule says I keep the base the same and I subtract the exponents. So this will turn into x to the 12 minus 5. And then y to the 6th minus y to the 8th. Notice it says m minus n. So it's top minus bottom. So that'll give you y to the negative 2. But now we have another rule to use, which says that if I have a negative power, that's this rule here, says if I have a negative power, I flip the sign of exponents and I flip the base, which means that instead of this being in the numerator, now this ends up being in the denominator. So this turns into x to the 7th over x to the 2nd. Because notice it says x to the negative power turns into 1 over x to that power. But when there's another number already here, there's something else already here, I don't need to put a 1 there. Okay, so same thing with this one. I'm going to start off by distributing that, that power rule. So negative 3 times 2, that's going to give me x to the negative 6th times y to the 2nd power. And that's because, remember, this is y to the 1st power to the 2nd, and 2 times 1 gives me 2, over x, and I'm going to put x to the 1st just as a reminder that when there's no number there, that is a 1 as my exponent, y squared. Okay, now y squared over y squared gives me y to the 0. X to the negative 6 over x to the 1, again, subtraction rule, that's going to give me x to the negative 7. Negative 6 minus 1 is negative 7. Okay, anything to the 0 power, going back over here, looking at my rule, anything to the 0 power is always 1. So that's going to turn into 1 instead of the y. And then again, to get rid of that negative 7, I'm going to put this in the denominator, x to the 7th. So this whole thing simplified to 1 over x to the 7th.